AS-Level Equations, Expressions, Identities and Inequalities. Exam Preparation Questions Part 2. In this video, we will start with the nature of the roots, a combination of straight line and curve. You will find this on page 29 or from page 29 in the grade 12 AS-Level Mathematics textbook, y equals mx plus c to success. I want to emphasize this again. First, go to the textbook, watch the videos, go through the videos of the examples in the textbook. Do the basics before you come to this final step, which is the exam preparation questions. Okay, when you have a straight line and a curve, you can, I just want to get the highlighter, you can solve the equation of the straight line and the curve simultaneously and form a quadratic equation. ax squared plus bx plus c equals 0. The discriminant b squared minus 4ac will then give information about the number of points of intersection. Intersection, 1 point, then it's a tangent. If it's a tangent, the discriminant will be equal to 0. The line is a tangent to the curve, it intersects at 1 point. And they will use in the question, you will see tangent or touch at 1 point. If it intersects it at 2 points, okay, so can you see? There is the 2 points. So then the discriminant will be bigger than 0. The line intersects the curve at 2 distinct points. And usually you will find that words in the question. And then if it intersects at no point, so then b squared minus 4ac will be smaller than 0. So the line and the curve do not intersect. Okay, but let's start with two graphs intersecting at 1 point, a tangent. I just want to say they love asking this type of questions. So please make sure that you are well prepared in these questions. Okay, let's start with the question. Okay. The equation of a curve, and this is the equation of the curve there. Let me just say, okay, where k is a constant. A line, this is the equation, is a tangent to the curve. Find the value of k. So first, form a quadratic equation by substituting the straight line equation into the equation of the curve. Okay, so the nice thing, this one starts with y equals, this one is also y equals. So I can basically just substitute that in there, and that's what I did there. And now I just simplify. So I take this over to the other side, leave, this is the only x squared, but now there's an x, and that is without x. Now I prefer to write a positive and rather take the negative in the brackets to make sure that you use it in the substitution. Okay, and then this is, if it's 4 and a negative times a negative, so it's 4 plus 2, so that will be 6. So if the straight line is a tangent to the curve, then the discriminant will be 0. So b squared minus 4ac equals 0. Okay, now don't forget that this will be a, this will be b, and this will be c. Okay, so I'm substituting it in. So this is going to be b squared minus 4a, there is a and there is c. And now I just multiply out. So I multiply, be careful here, first multiply out the brackets and then multiply the negative 4 in. Okay, then rearrange and you will get your quadratic equation. Now first simplify it before you factorize. So I think it can divide by 9. Okay, so divide 9, 9, 9. And this is what I get. And now I factorize. And if I factorize, I say 3 and 3, 1 and 1. And then 3 plus 3 will be 6, and the signs will be the same. But at the end, this bracket equals 0 or this, but the value of k is 3. That is the point. Okay, and that's what I did. Okay, let's just go to the next page. I want you to stop the video and I want you to do number 1 and number 2. Again, you can continue the video as soon as you are finished. Let's start with number 1. Again, also, as soon as you finish with 1, then stop, just check to see if you are correct, and then you go on to 2. Okay, but I'm going to start with 1. So, my two equations, 4y equals x plus c, where c is a constant, is a tangent, do you see the word, to the curve. So, there's the two equations. And they're at the point P on the curve. Okay, so, and then this is the curve. Now, if you check these equations, you will see it's not y equals y. This is 4. Now, you can divide by 4, but then you are going to encounter fractions. And you always try to avoid fractions because it's so easy to make mistakes with fractions. So, the best would rather be to leave the x and to take the c over. Okay, and now say this is equation 1. Oh, I forgot to put that square there. I see now, luckily. I'm looking for my quadratic. And this is equation 2. So I'm going to substitute equation 1 into equation 2. And that is going to give, okay, so there, can I just show you where? There, I'm going to substitute this. So let's just do this. I'm going to say it's going to be y squared equals 4y minus c plus 3. So y squared, okay, I bring this over, minus 4y plus c minus 3 equals 0. Because if it's like this, I can already see that this is a. This is B, and this is C. So I'm going to start by saying a tangent, so I know the discriminant will be equal to 0. So B squared minus 4AC will be equal to 0. So it's going to be negative 4 squared minus 4A and C minus 3. And that is equal to 0. So this is going to be 16 minus 4c plus 12 is equal to 0. So negative 4c, and 16 plus 12 is 28, and if I take it over, it's negative 28. So I divide negative 4, I divide negative 4. So therefore, the value of c will be equal to 7. Okay. I forgot to show you that this was question A. But now I'm going to go to question B. Now I find the value of C, but find the coordinate of P. Now I'm going to use this because I already there. So as soon as I substitute C, then I will just have one unknown. If I substitute it, say, in there, I still have 2. And the same, there's not a C. So I'm looking for an equation where I will just have one unknown after the substitution of C. So I will just start there, and I will just say y squared minus 4y plus 7 minus 3, and that's equal 0. So y squared minus 4y plus 4 is equal to 0. And now I'm going to factorize. So let's make it, if I'm going to quickly look in that factorization, it's 1 and 1 and 2 and 2. Because 2 plus 2, this is group A, it's going to give me the 4. I'm going to add, do you see, because there's a positive, the overcross product. The signs are the same, but both take the sign of the middle term, a negative. And this is y. So I'm ending with y minus 2, and that's equal to 0. And again, it's actually so obvious, but let me just put this step in. and I just see that the value of y is the same, okay, due to the tangent, and it's going to be 2. Okay, but I'm not done. So I have y now. Now I'll go back to my equations, and I say, okay, I have then y and I have c, so I'm able to find then x. So let's just go and put it in that equation. So we are going to say, okay, let's just go a little bit higher still. So we are going to say 4y is equal to x plus c from the beginning. Okay, so 4, and then I put the 2 in, and I put the c in, and then this is going to be, oh, c is not 2, c is 7. And 4 times 2, can I just show you? C is 7. 4 times 2, this is 8 minus 7, and that's x. So therefore, x is 1. But they call it points P, so I end up by saying, therefore, P, first the x value, then the y value, and that is my final answer. And that's how you do question number 1. Okay, let's go for question number 2. I just want to move it down. Okay, there it is. Okay, let's start with number 2. Okay, number 2. The equation of a curve, there is the curve, and the equation of the line, there is the line, where k and a are constants. So nothing about the tangent yet. But now, go on. Given that the curve and the line intersect at the point with x coordinates 0 and 3/4, find the values of k and a. I'm not with tangent. I just want that. Okay, but let's start by making it one equation. So y is equal to 4x squared minus kx plus a half k squared. That is the one equation. Okay, I just want to move up here. Let's go to the second equation. So the second equation is y is equal to x minus a. Okay, now luckily both starts with y, so it's actually very nice. I'm just going to throw this in there. So I'm going to say x minus a is equal to 4x squared minus kx plus a half k squared. Okay, then I'm going to take everything over. So 4x squared minus kx, I can bring that one over, so minus x plus a half k squared plus a. Okay, so let's just arrange this a little bit. So I'm going to say this is 4x squared. Now, as you know, I prefer to write the positive there. And then this last one is a half k squared plus a. Okay, now what am I going to do? Now I'm going to substitute these values. I have the x coordinate and it's 0 and then it's 3/4. So I'm going to substitute it so that I form two equations which I can solve simultaneously. Okay, so let's start. If x is equal to 0, then it's going to be 0. So if x is equal 0, so 0 equals 4, and I put a 0, plus negative k, negative 1, and I put a 0, plus a half k squared plus a. Let's just simplify this. Luckily to the 0, this is 0, this is 0, so I'm actually just end up with half k squared plus a. I can make a, so let's just say, therefore, a, I'm taking this one over, so it's equal to negative a half k squared. Okay, so that is if x is 0. Okay, let's go. If x is equal to 3/4. Okay, now I'm doing exactly the same in there. So I say 0 equals, and I start and I say 4, and I'm going to go for my 3/4 plus minus k minus 1, and I go for my 3/4 plus a half k squared plus a. So 0 equals. Now this is going to be 4 over 1, and this is going to be multiply 9 over 16. I'm just going to keep it first like that. This is going to be negative 3/4 k, just bring it in front, negative 3/4, okay, and then it's going to give me, okay, so a plus a half k squared plus a. Let's just simplify it further. Okay, I'm doing it a little bit. So 4 can go in 1, 4, 4. So I'm doing it a little bit long. You could have just used your calculator. So 9 over 4, I'm just going to say minus 3 over 4. I'm bringing that one. So then this, so minus 3/4 k plus a half k squared plus a. So if I simplify, this is going to be 6 over 4 minus 3/4 k plus a half k squared plus a. Okay, so this was now, it's almost like equation 1, and this was like equation 2. But now I can substitute. If you want and you don't want to get, I could have called this 3 and I call this 4. So substitute, because I already had a 1 and 2. Substitute equation 3 into 4. Okay, and I'm going up and I'm going to do that. So I'm going to say 0 equals, this is 3 over 2, or 1.5, minus 3/4 k plus a half k squared. And there I substitute. Oh, and I love if this is happening. Because what is happening? This cancel out. Oh, and now it's so easier to simplify. So then I have 3/4 k equals 3 over 2. And if I divide, it's, I'm using without a calculator a little bit. So it's 3/4 divided by 3 over 2. So it's actually 3/4 multiply 2 over 3. And this is simplified. So this is going, so the value of k, let's just see if I have it correct. Okay, so this was 3/4 divide by 3, multiply 2 over 3. So my value of k, just quickly want to check something. Okay. Okay. But my value of k, so therefore, my value of k will be equal to 2. I just want to see why it's not working out there. Because it's, oh, I see why. I see why. I want to show you quickly. It's usually when your k is not. So it was, in this k, it was, I just want to show you, because it was 3 over 2 divided by 3/4, which will then give me 3 over 2 multiply 4 over 3. Now it will work. Do you see? So 4 divide, and that will be 2. I just wanted to do that calculation correct. Okay. So let's just go on. Now so the value of k will be equal to 2. And what did they ask you? Find the value of k and a. So I must still find a. So let's just go. So a was negative a half k squared. So it's negative a half, and in the place of k, it's 2 squared. And that would have gave me negative a half, and that's 4 over 1. But it's negative 2. So therefore, the value of a is negative 2, and the value of k is 2. And that's how you do number A. So number A is actually not nature of roots. You could have done it just by using your own old algebra knowledge. But now, and they like combining it, because now the next question is nature of roots. Okay, so let's just go to that next question. Okay, I just want to make space nicely. Okay, so let's look at number B. Number B. Given instead that A is equal, so now you ignore what the A is, you make a new A, find the value of K. So it means you start with that same equations, okay? 4x squared minus kx plus a half k squared. But if you come to this one, then it's y equals x, and they tell you the value of A is negative 7 over 2. That means y is equal to x plus 7 over 2. Okay, and now they say find the value for k when the line is a tangent. Okay, so now it's almost, I'm going to first substitute this equation in just like I did, but now there's a value. So it's 7 over 2 equals 4x squared minus kx plus 1.5 k squared. Okay, I don't like it if it's run into each other. Okay, so now I take it over and I'm going to get 4x squared minus kx. I bring that one over, minus x. And then it's going to be a half k squared. Bring that over, minus 7 over 2. Okay, I can now rearrange it a little bit. You know, I like the plus and I put the negative rather in. I take x out as a common factor. And this is my value of c. The nice thing, I'm familiar to some of the values already. Okay, so now this is going to be my A, this is going to be my B, and this is going to be my C. So I'm going to start by saying a tangent, then the discriminant is equal to 0. So B squared minus 4AC is equal to 0. Okay, so basically, I'm just going to now go and say, okay, so if I look at this, I'm just going to substitute. Just want to get my pen. So minus k minus 1 squared minus 4a4 c, it's half k squared minus 7 over 2, and that will be equal to 0. Okay, now I simplify. If I simplify this one, you can do it on the side, otherwise I square. So remember, it's k squared. I multiply and I multiply with 2, so it's going to be k multiplied 2, so it's going to be 2k, and I squared and it's going to be 1. But you can always go and just not to make mistakes, you can write it out there. Come on. And you can just multiply it out. That's also what you can do. Okay, then I'm going to multiply this one. So this is negative 16. Multiply, so it's going to be 8. Okay, let's just say negative 8k squared. This is negative 16, so I'm going to do it again here. So, sorry, it's negative 16, and then it's multiply with another negative. You see, negative 7 over 2. Okay, usually I would do it on the side. No, it's actually very bad what I'm doing now. Never do it in between your working. So, no, I don't like to do bad things. Okay, so rather take another or write on another. So if I want to see, I do it on the side. So negative 16 multiply, and you can just take a calculator. Today I don't want. Okay, I do it the long way. So it's going 1 and it go in 8. So it's going to be 8 times 7, so it's going to be 56. So plus 56, and that's equal to 0. And now I'm going to simplify. So there is my k squares. So it's get negative 7k squared. There is k, so plus 2k. And 56 plus 1, that will be 57. And that will be equal to 0. Okay, now just get the negative. So divide by negative or multiply by negative, doesn't matter. But you don't want a negative in front of the square. Okay, now this factorization is a bit more challenging, but it's in group A, so you must add the over-cross products. So it's 19 and 1, and it's 7 and 1. So if you're going to say, in this case, okay, let's say, no, 19 and 3, and 7 and 1. Because if you now say 7 times 3 is 21, and this is 19. And if you're going to say 21 minus 19, it's going to be 2. And the biggest over cross product, and be careful, this is the biggest, that gets that sign, so a negative, and this one gets a positive, and it's k. And then I'm going to say 7k plus 19 and k minus 3, and that's equal to 0. And now I'm going to put both brackets equal to 0. So it's either this one that's 0 or this one that's 0. So 7k equals negative 19. So divide 7. So therefore, the value of k is negative 19 over 7, or the value of k is equal to 3. What I like about this example is usually when you get an example which is a fraction, you think, it's not correct. But this is the correct answer of this question. And this is how you will do when they intersect at one point. Now, the next part is very long, and that is why I'm rather going to do it in part 3 of this video. I have a copy of a textbook that you can use, because it's very important that you go to the basics, to the textbook. Then you can find a copy of the textbook or try to buy a copy of the textbook at one of the following bookshops.